Good. Hello, everyone. My name is Dawson. I am a principal vulnerability researcher with GitLab. I've been doing offensive research, or offense security for about 20 years now. I've been with GitLab for 6, and I've lived in Japan for about 20 years. What are we going to talk about today? First is, stand over here a little bit more, the process. So obviously, if we're going to look at dependencies, we have to collect them. So the system that I built actually pulls down lots of these artifacts from the artifact registries, and then we're going to do some analysis of those, looking at the behaviors of what these packages are doing. And then finally, we're going to look at the results, just do some statistics on it. So let's take a look at the process. So this might be a little bit hard to read, but there's 2 primary components to the system that pulls in packages. We have GitLab, obviously, on the left side here, and then we have our GCP network. So the way this works, it's a push-based model. So we're pushing Perls into, a Perl is just a package URL, so you can figure out which package manager to talk to, which package to download, etc. So we push Perls into this API service. API service then says, hey, processor, go to connect to this package manager, whether it's PyPy, NPM, Maven, whatever, download them. They're zip files usually, so extract them. And then we're going to, if they're Maven or NuGet, we're going to decompile them. We're going to create a Git repository. We're going to tag each version that we download. So we download every single version of a package. So if it's like AWS's SDK, that's like 1,000 versions. So we download every single version, extract them, tag them, push them. And then we have this KGS service that kind of handles the security of creating GitLab projects and personal access tokens to really limit the blast radius, I guess you'd say. So that is for downloading packages. Now, when we want to run tools against these packages, we have a whole tool system where we basically, it's a very similar process. We have a Perls, we push them into the API service, it redirects to a processor for tools. That tool processor creates batch jobs and then uses GCP batch to basically say, hey, run this tool against 10 Perls, and it just goes off and does that. And then a very similar process where it's also Git tagging and it's Git pushing. So now we have 2, so you can see here there's a /sh8/shard repo. All those tag versions will be the same. So if we run a tool, it'll be tagged with the output of that tool will be tagged with the same version of the repository we're analyzing. So it's a really clean way of using the power of Git to really store a lot of data. Because if you think about a package, most of the code doesn't change. So to store this in anything other than Git doesn't make sense. All right, so what are we even doing here? So for each package, as I kind of mentioned, we pull down the source for this. This is for running tools and our analysis. So for each tag version, we git pull that tag. We run our analysis. We get the output. We git tag and push that tool output to our repo. And then we just loop over every single one that we want to run our analysis against. And our analysis, in this case, is a tool that I wrote called libbehave. It's about 130 semgrep rules. Does anybody here know what semgrep is? Okay, a few. So it's a static analysis system that you can use to create very simple rules. I'll show one in a second here to basically extract metadata or information from a source code. So what are we looking for? I'm looking for lots of stuff, mainly things that are considered kind of risky behavior. So HTTP clients, outbound requests. Is a package like, I don't know, opening a TCP socket when maybe it shouldn't be? Is it reading environment variables? Is it executing OS commands? And then other things like zip file extraction. So a lot of developers now are better at looking for path traversals like .. Not so great when it comes to zip files. There's still a lot of zip slip style vulnerabilities where you just archive an attack. Some tool automatically unzips a file and it automatically overwrites some system configuration or whatever. So we're also looking at kind of various just informational level stuff, like is it using JSON, is it using YAML, is it using gRPC for transports, protobuf, etc. And then also we want to catalog which frameworks are being used, because it's just kind of nice to know if there's framework-specific issues that this package has. And then finally, we have just like a whole set of cryptography, regular expressions, some infrastructure stuff. Is it going to be deployed on GCP? Is it going to call AWS services, etc. So this is a semgrep rule. It's pretty straightforward. So we're just basically matching any of these, like, and this is in this case, we're looking for a TCP socket client for Golang. So we're saying, okay, anything that calls dial with the protocol, and then we have a regex that says it's TCP4, TCP6, etc. We're going to flag that as being, this is going to open, or this is a TCP socket client, so mark that as a socket and a transport TCP. All right, on to the results. So I ran the analysis on about 7,245 packages. 6,000 of those had advisories. So my main source of input pearls in this case was our advisory database. GitLab has a composition analysis tool where we run it to find known vulnerabilities. So I took that database, I took all the packages that have vulnerabilities, and I merged that into our primary source of packages. And then to get kind of a cross-sampling, I took about 200 packages, a little less than 200 packages of each language that don't have a known advisory yet. So overall, there was 930,000 package version combinations, which I think is like, I forget the exact rule, but it's like 100 versions per package. Again, you're going to have outliers like Amazon's SDK, which has thousands. And then finally, we have about 137 million total findings. But a lot of these findings are duplicates because, again, it's the same, for the most part, it's the same software that's being analyzed over and over again. It's just minor changes between version bumps. Overall, we had about, let's see, 7 supported languages. NPM took up the most of our advisory database, which shouldn't be a surprise to most people. Maven coming in a close second, and then Ruby coming in last. So what are some challenges with using behaviors as a signal for if software is vulnerable or not? First off, there's a lot of these artifacts that are published that actually have scripts and code that's not related to the actual dependency that you're using. So it's really hard to sometimes kind of suss out what that is. A lot of them have installers, such as like Python setup py scripts, which are going to be executing OS commands. Or you'll have CLI tools that are included, which again are executing OS commands or doing something else, reading files, etc. There's packages which include examples. Even though they're published, they're going to include their example code, which can trigger various behavior rules. A good example of this is Pi0MQ, which is a message queue client server system. The Python client included an example of using Pi0MQ over the network using the zero-MQ protocol, but they're using pickle and unpickle for deserialization. So if you're not familiar with Python's pickle, it's basically remote code execution because you can serialize an object and then have it execute code when it's deserialized. So that example code, while it's technically not vulnerable as an example, someone must have looked at it because someone who was importing Pi0MQ as their dependency used the same exact example code and then ended up having a CVE attributed to it because they just basically took the example code. So be very careful when you're creating examples to use secure examples. Some other issues, code that's only vulnerable depending on the context it's used. This is a hard one. So if you have like a function that executes an OS command, but that's only called with a hard-coded string from one place in an application, sometimes it's really hard to determine if it's actually vulnerable or not, or exploitable, I should say. Other issues, this one particular is impacted for Go because when you publish a Go module, it can actually be a full-blown application. So you can say, here's my full application, and then Go's artifact registry, their Go proxy, will basically store it, and then we can just pull it down as a Go module. So it looks like a dependency, but it's actually a full-blown application. Other challenges for using behaviors as signal are lots of features are just very common. Lots of dependencies are going to read files. They're going to read environment variables. They're going to use JSON. So that's not always an easy way to determine if something's going to be as something that you want to look at risk-wise. And for this one, for me particularly, maybe not everybody else, but determining what the latest version of a package is actually really hard in some cases because not many developers know how to use Semver properly. Especially if you look at the Java ecosystem, there's a lot of dot finals and snapshots and other weird stuff. So I think these slides are online. If you click version, it's an article written by my coworker Julian, who wrote a Semver dialects parser, which handles all that stuff for you. It's a really good resource if you're ever dealing with Semver. All right, let's take a look at an example here. So we have the package PyPy Jupyter client. Anybody? Well, we talked a little bit about Jupyter, but anybody know what Jupyter is? Executing Python code? Yeah. So it's like executing code as a service. So one of our rules triggered on them, basically their session objects, you can pass in how you want to deserialize the message. It can be JSON or it could be pickle. Or the last one, you can just pass it a string and it'll just import that. And I guess you can just execute code that way. So this looks, to me, as a security researcher, pretty vulnerable. But if you think about the context of Jupyter Client, it's executing Python code. So is it really vulnerable? Because that's the whole point of the service, is to execute Python code. If you read the session object, it basically, as I mentioned, you can basically pass it a string and it can execute whatever you want. All right, so let's look at some numbers here. So 50% of packages contain some form of code and OS execution, which shocked me. This doesn't matter with or without advisories. We just like to execute OS commands, is all I can say as developers. 30% of packages with advisories use an HTTP client functionality, and only 13% of the packages that I analyzed do not utilize an HTTP client. So this, to me, probably leans towards lots of SSRF style, like server-side request forgery. You basically trick a client to making or a server to make a request outbound. 20% of packages with advisors have some password-like functionality or keyword. This is versus 4% of packages that don't have a known advisory. Again, this probably points to full-blown applications being included in the data set, not so much that dependencies are just randomly having password-like functionality. So here's the kind of top 14. On the left side here, we have all total packages. In the middle, we have findings without advisories. And then on the right side, we have, or I guess, yeah, you're right side, findings with advisories. So I kind of noticed there's a spread of about 10 to 12% difference between with advisors and without advisors. This might just be the low package count. I'm hoping to do a bigger set of data analysis later on once I get more non-advisory-based packages. So how about getting signal from the number of unique behaviors? So let's say you have some packet dependency you're about to include in your software, and it triggers like 30 of these behavior rules. So what I noticed again with Go, 48 of these packages that had above 30 unique behaviors, almost all of them basically were full-blown applications. And this Yaklang one had over 59 unique behaviors, which was wild to me. But if you go to their website, what they're doing is wild. It's this entire system. It's very, very complex. The other ones, 2 are in PHP or Composer, and the rest are in Python. And again, these are all apps and not libraries. So high unique behaviors are going to probably lead to a package being more of an application and not something, a dependency that you would include. Only 10 packages without advisories had more than 15 unique behaviors versus 662 packages that did. So about 10% have more than 15 unique behaviors. So again, a unique behavior is like, does it open a TCP socket? Does it make an HTTP request? How about lines of code? Lines of code, yep, pretty indicative. We have with advisories 103. Obviously, if you have more than 1 million lines of code, you have a higher chance of having a vulnerability, bigger attack surface, more features, etc. So I don't know how much we can glean from that, just except for saying try not to have much code. How about combinations of behaviors? So if it reads a file and opens a TCP socket, does that mean there's going to be a higher chance of a package having an advisory? Not really. Turns out almost all packages share the same set of similar combinations, regardless of whether or not they have an advisory. So I tried different models of okay, what about execution of JSON? Nope, it's always these 5 are common across all types of packages, which if you think about it, makes sense. The only difference between a package with an advisory or a CVE and one without is one hasn't had one found yet. That's basically all we can really tell, at least from I learned from my analysis. So this is testing volatility, so how much unique behaviors change over a package lifetime. I thought 2 things when I first saw this. One, get hue, maybe my data's wrong, and the other one, and it really reminded me of Hokusai's The Great Wave off of Kanagawa. But yeah, so I looked at this, I'm like, get hue does not look right. There's something weird going on there. And just so you know, what I did here is for the versions, I collapsed. So versions 4.83 to 4.912 all had 6 unique behaviers. But then all of a sudden at 4.9.12, we jumped up to 60. Okay, that needs some investigating. So I checked out, I opened up the source repository, and the first thing I see is a SSH key just sitting in the repository. So keep in mind, when I'm pulling down these packages, I'm not pulling it from GitHub's source. I'm taking it from the package registry, just like you, if you're doing PyPy setup install, it's pulling in the same information. So they accidentally published this SSH key along with every single one of their vendor dependencies, which made sense. That's why I'm getting such a high hit rate on unique behaviors, because they included literally everything for their application inside of their particular artifact, which they should not have done. Later versions and previous versions, they correct their issue. We did test the key. It did not work. So at least it didn't work against GitHub. Don't know what else it could have gone to. So yeah, that concludes my talk. Just a couple of things. So deriving signal from features of packages is actually hard. The biggest kind of signal that I could really determine from this was more code, more features, more chances of bugs, higher attack surface. But what was very kind of interesting is to see the differentials between packages. So as a new feature suddenly exists or a new behavior suddenly exists, that's where I think the real value of looking at behaviors comes from. And yeah, and just looking at behaviors is just another way to add details to your risk profile for your dependency. So that pretty much concludes it. I don't know if we have time for questions. Thank you.
Any questions?
Oh, well, I have the microphone, so too bad.
He wins.
No, I'm just joking. So I'm going to put on my professor hat for a
Sure.
minute here, if that's okay. So is what you're saying that everybody who has a large package should just break it into 2 or more smaller packages and then all the security problems are going to go away?
They will be distributed evenly. Let's put it
Okay.
that way.
Well, I wonder if that's actually true, because I wonder if sort of per line of code did you break things down in that way rather than looking at just CVEs per package? Because I would imagine actually taking a bunch of components from different sources that are all small and are namespaced and maintained by different maintainers to do a larger piece of functionality would be more likely to be more buggy than having something under the purview.
It's not as cohesive for connection.
And you have dependencies changing.
Yeah, you will see that with parser differentials.
Mm-hmm.
So a lot of parser-based bugs, like you have an HTTP proxy in front that parses it one way, and then you have a load balancer in the back that's parsing it a different way, and all of a sudden it can get rerouted to a vulnerable or a service that it shouldn't have access to. So you're right. I did not do that analysis. I don't know how I would do that analysis. It sounds super interesting, but
well, let's talk about it later.
all right.
All right. Thank you.
Yeah.
Yeah, sorry about earlier.
No problem.
I guess I'm interested in trends. So I'm curious, do you find that over time, because of tooling and those type of things, that number of vulnerabilities kind of goes up or down? Have you noticed any changes with that?
This was the first analysis I've done with this. And again, this wasn't really vulnerabilities. This is more of risky behaviors. But I'd say, if you look at this, the CVEs, number of CVEs that are being issued per year, it's going up. But again, CVE is not a great, software is software. It's really hard to say, just because you have a CVE, it's more, and actually, I don't think you can say just because something has an advisory means it's more vulnerable than something else. It just means it hasn't been looked at yet, or this one hasn't been looked at yet. So.
I'm just basically trying to see if a lot of people are using, or a lot of teams are using a lot more tools. So I'm just trying to see if the tools are actually helping or.
Oh, you mean
or not?
using security tools? They're helping to create lots of alerts. That's probably my answer for you. Okay. I think it's hard to say.
Okay, thank you.
Any other questions?
Are your patterns open source?
Those ones are not, sorry. Yeah. Yeah.
Okay, again, thank you so much, Zach.
Thank you.